Here in Chapter 6, we're going to introduce the normal probability distribution. And this is one of the most important aspects of statistics, as it'll be something that we'll see in almost every single section that we'll cover from this point on. And we think of the normal distribution is part of a class of distributions known as continuous probability distributions. So if we remember, a continuous random variable is one that takes on continuous data. So for instance, a random variable that can take on any real number would be an example of a continuous random variable. And continuous random variables are described by their probability density function, or a PDF. And in particular, a PDF is sort of the continuous version of what we had in the discrete case, when we had each random variable has an associated, each value of the random variable has an associated probability, and over all the random variables that x can take on, it should sum to 1. With a PDF, because it's a continuous distribution, the sum is not possible to compute because there's infinitely many infinitely many values that the random variable can take on. And so we'll look at it more like the total area under the curve that's given by that probability density function has to equal to 1. And then every point on the curve should also have a height that's somewhere in between 0 and 1. For a uniform probability distribution, when we say that a random variable is distributed uniformly, then it takes on a constant value at all values between two values on an interval. And so the height of that distribution is going to be such that the rectangle that's formed here has an area of 1. So we know that the total area under the curve has to equal to 1. And in this case, the sides of the rectangle will have b minus a for the base. And so the height has to be 1 over b minus a to ensure that we have an area equal to 1. And to find the probability that a random variable x falls in between two values, what that amounts to is finding the area under the curve. So in general, if I'm looking at the probability that x is between a and b, we're looking at the area under the probability density function between those values a and b. So in this example here, we have the arrival time of a bus is somewhere between 0 and 30 minutes, and it's uniformly distributed. So we know it has this rectangular shape for its probability distribution function. And somewhere in between 0 and 30 is when that bus will arrive. Now suppose I want to find the probability that the bus will arrive between 10 and 15 minutes. So we can imagine what we're trying to find is the area of that region in the graph between 10 and 15. So if we know that it's uniformly distributed between 0 and 30, then its height will be 1 over 30. And so the area of this rectangle here, we know that it has a base of, well, it goes from 10 to 15, so 15 minus 10 gives us the length of the base. Oops, 15 minus 10, which is 5. And then the height would be 1 over 30. So it'll be 5 times 1 over 30, which is 5 over 30, or 1 over 6. So the probability that it will arrive between 10 and 15 minutes is 1 over 6.